All right, so 3 notes here. Um, and we're talking about the end behavior of polynomials. And what that is that, let's say we have a graph here, and I'm just sketching something kind of funky. The end behavior is that at the very end of it, it's going to maybe go up and down and have some loops and all this other stuff. But at the very end, once it's done turning and it heads off in a direction, what happens at those ends? And it turns out it's very predictable behavior, and we'll talk through right now how you know what's going to happen at the end behavior of a polynomial function. So first part here is that let's talk about the degree. The two main things you're going to look at is the degree odd or is the degree even. So let's say we had y equals um, 3x to the third plus 2x minus 8. And I don't know what this looks like exactly, but we can predict the end behavior based on our leading term. And we're looking at, first off, is the degree odd or even? And so here it is. The degree is odd. Now our leading coefficient is positive. And what happens when it's a odd degree leading coefficient, or our leading term? So odd degree, so third degree, and the coefficient is positive. And what happens is that the ends of our graph go in opposite directions. One's going to go up and one's going to go down. But that means that either we could have it ending like that, or maybe starting at positive and ending at negative. And so which of these is it going to be? And when your leading coefficient is positive, actually let me color code it because it's going to be the blue one there. When your leading coefficient is positive, it's going to go in opposite directions, rising from left to right. Meaning as you plug in more and more and more increasingly negative numbers, so it heads towards the x value is heading towards negative infinity. And what's going to happen is that, well, let's kind of in our brains plug in negative infinity or negative some number. So a negative x to the third means x times x times x. And so a negative times a negative times a negative gives us a negative. And then you multiply that by the positive coefficient, it goes to negative. So how we would read this limit notation, this fourth box here, is that it says that f of x, and that's kind of y, y will approach negative infinity, so it's going to get lower and lower and lower and lower as x gets more and more negative. So the farther left we go, the more and more negative, the farther down y is going to be. Conversely, when f of x, and again, you can think of that as y, we'll get more and more and more, we get more and more positive and head more and more towards positive infinity, so it's getting higher and higher and higher. The farther we head to the right, the farther the x heads towards positive infinity. So positive infinity, negative infinity. The more farther to the right that it gets for x, so the more we head towards positive infinity, the higher and higher our y values will become. All right, so similar situation. What if our degree is odd, but the coefficient is even? So this time I changed it to -3. So, sorry, our coefficient is negative, not just even, but if it's a negative number. So here, it's still going to go in opposite directions. Notice that if the degree is odd, it's always going to be in opposite directions. That part didn't change. What changed was that last time it was rising from left to right. This time it's falling from left to right. So it's going to be more along this line here. And our limit notation says that y heads towards positive infinity as x goes towards negative infinity. So the farther left we go, the more and more negative we get with our x values. The y value is going to get higher and higher and higher. It heads upward. On the other side of our other end, on the positive side, as x gets farther and farther positive, y gets more and more negative. So f of x approaches negative infinity, heading on down here, as x approaches positive infinity. All right, there's for odd functions. Now for even ones, and you're pretty familiar with one even function in particular being a quadratic, so x squared. Here, our degree is even. And notice that when it's even, it's going to go the same direction. Our end behavior, both the left and right side, so that where x is approaching negative infinity or positive infinity, both sides do the same thing, either with a parabola, even having both sides head up, or both sides head down. They're always going to go the same direction when it's an even degree. And what changes whether or not it's heading up or down is whether or not the coefficient is positive or negative. So if it's positive, they're going to both open upward. As x gets more and more and more negative, so it heads farther and farther left, that value gets squared. So think if we had, this is really x times x, even if they're both negative values, once I multiply them together, I get a positive. So as more and more the x gets negative, y gets more and more positive. On the other side, as x is more and more positive, those positive numbers get multiplied together, they get bigger and bigger, and as you head towards positive infinity, y also heads towards positive infinity. So y is heading to positive infinity as x is heading to positive infinity. Then if the coefficient was a negative number, like let's say negative 7, now we've got a negative coefficient. The degree is still even, so it's still going the same direction, but now they're both heading downward. As x is approaching negative infinity, so as it gets farther and farther to the left, y approaches negative infinity, meaning it falls farther and farther. On the other side, as x approaches positive infinity, then y gets farther and farther negative. All right, hope that helps.